So Gabe, since you like to talk so much.
I was not the only one who was talking.
No, but I'll call on them in a second. But I can only call on one person at a time. So if I'm looking at angle A, what is 48 in respect to angle A? Which side?
Opposite.
It's opposite. So you're saying that 48 is the side opposite from A. By the way, Kyson, what do we call angle A in these trig ratios? It's hard to understand when we don't know the proper terminology and language.
Well, you said
Rin? It's our what, Kyson? Because Rin just gave us the answer. The reference angle. Because it's an angle, right? So it is opposite from angle A. Everything is in reference to angle A. Okay, and so, Matthew, what is the 14 in respect to angle A? Notice we have our hypotenuse, we have our opposite, the only thing left is adjacent. So which trigonometric ratio are we dealing with 48 divided by 14? The opposite and the adjacent, which is which ratio? Tangent.
You got that age.
They're up on the bookshelf.
What bookshelf? Oh, I see it.
Okay. Tangent of which angle? A. And so because the tangent of A, Bashar, are you paying attention?
Yeah.
Because it looks like you're talking to the people behind you, which is nowhere near this board. Tangent of A is 48 divided by 14. Therefore, the tangent of A is also 24 divided by 7. Say again. Yeah, we needed the 24 divided by 7 because that's what it already gave us, right? And so that's the whole thing is we had to rewrite it as 48 divided by 14 first to figure out that was the tangent of A. Okay? We good with that?
Yeah.
What's the issue you have with it? Well, look at the problem in number 3. It told us which trig ratio is equal to 24 divided by 7. Right? But is there a 24 or a 7 up on the triangle? We had to figure out the 48 divided by 14 is 24 divided by 7. Then we knew the tangent of A is what we were dealing with. We good with that now? Alright. Ready to look at number 11. Now, I would assume on number 11 the biggest issue is why we got left with the square root of 3. Now, we haven't done it yet, but I will go ahead and tell you, starting tomorrow, we're going to look at how we can get that sine, cosine, and tangent at 30 degrees, even without the triangle being given to us, or sides given to us. But that's something for tomorrow, or for tomorrow. I had to go ahead and give you these sides, but what is number 11 asking for? Cosine of 30 degrees. To earn maximum credit, what is the first thing we should write down, Rose? Huh? What? You don't understand? Then why haven't you asked a single question yet? What question? Rose. Did you? Oh, did you get distracted a lot? Don't act like you don't know what I'm talking about. And I'm talking about today. We are, what, 40, 35 minutes into class? But have you asked any questions? No. Y'all, stop sitting there silently. We're talking about other things. Ask questions. I'm more than happy to answer them. Okay, so I'm going to go to someone else. I'm going to come back to you on one of these in the future, okay? Brandon, what do we need to write down first for the cosine of 30 degrees?
Is this normal?
Say again. Did you say something? Or is it somebody else?
Adjacent side, what's it called?
So the adjacent side? So adjacent to what? to 30 degrees, right? It's always in reference to that angle divided by the hypotenuse. Now, some of us may be looking at others like, where in the world is all this coming from? Does anybody remember a acronym to help us remember the ratios?
So que oui.
So,
So.
Now, remember, this is just to help us remember. It's just an acronym to help us remember. And what we're saying is that the cosine, what's the A? Adjacent, what's the H? Hypotenuse. Now, that's just an acronym to help us remember cosine, adjacent, hypotenuse. That's it. But that means that the cosine of 30 degrees is equal to the adjacent to 30 degrees divided by the hypotenuse. That's where you need to start on this. So London, which side is adjacent to our 30 degrees? Might help if you circle your reference angle first. What side is adjacent to that?
Okay, listen.
Well, we need an adjacent and a hypotenuse, so they can't be the same. Where do you see an A up here? The 8? Okay? Alright, did everyone agree with the fact that adjacent is 8, or do we need to push back on that? Brooke, what are you thinking? That one? Okay, why do you think that one's 4 squared root of 3? Oh, actually, let me pause, say this for a second. Alana, just the word adjacent, what does that mean? Beside or next to. So Brooke, why are you thinking this is adjacent instead of this? I mean, that's next to it as well. How do you know? Right. You good with that, London?
Okay.
That 8, hey. Y'all, shut your mouth sometimes. Unless you're involved in the whole class conversation, be quiet. Some of us need this. And even if you don't, you're preventing others from getting this information. So, notice we want to label our hypotenuse first, because that's going to help us identify the adjacent. Because now the only side that is adjacent or next to 30 is this one. And I'm done at this point. So my adjacent side is 4 square root of 3 divided by 8. And a lot of us got to this point, but we didn't know what to do from here. Is that safe to say?
I don't know how to do it.
You don't have to put this in the calculator. Hey, stop and listen. The square root of 3 you cannot simplify. Pick up a calculator though and do 4 divided by 8. It's not 2. 4 divided by 8.
1/2.
1/2. Remember, you have a calculator for a reason. Pick up the calculator and do 4 divided by 8. It's 1/2. Which means this 4 becomes a
Half.
1. This 2 or this 8 becomes a 2. So the cosine of 30 degrees is equal to 1 times the square root of 3. Hey, that's just square root of 3. Divided by 2.
Oh, I'm still on the screen.
Well, this would earn you the full credit. Remember, that's the next answer. There is no answer that's 4 square root of 3 divided by 8. The next question, or the next answer that we were looking for was the square root of 3 divided by 2. Now, I also want to actually, I'll wait a second for you to write this down. And then Brandon, let me say one thing and then I'll answer your question. London, take the hood off your head, pick your head up, and let's learn something. Brandon, come on, head up. Put the glasses back on. Stop trying to fall asleep on me. Woo! Alright. I need everyone's attention on this. Because a detail that a lot of us are missing is this. Have I ever just written a fraction or a ratio up here? No. You need to say the tangent of A is equal to this ratio. The cosine of 30 degrees is equal to this ratio. You need to write the trigonometric ratio equals the ratio. You got to say that it equals that thing. Otherwise, you will not be earning full credit. Yes, sir. Yep.
5, 6, 7,
I hear music, dude.
9,
All right, so we got 3 and 11. This next one, 4.
10. Oh no.
Terrence, why are you talking?
They ain't gonna leave you alone.
As I stop touching me, bro.
Well, I'm not whacking, bro. I got to about iron.
All right. You're in high school.
You just tickled me.
But oh my mama ain't even touch
Move up
me.
here, Anton.
I ain't even touch
Terrence,
you.
stop.
I'm on the boss, I ain't even touch that nigga.
Terrence, you watch your language. We don't use that term in this
I ain't
class.
even touch that dude.
That's not what you said.
That was a bad word.
All right, who asked for number 4? Which group? Do we remember?
Nope.
Number 3.
Oh.
Because I think it was 3, 11. Was it y'all? No? Was it you? Y'all asked for it? Okay, so Ren, any idea how to get started on cosine of angle A now? Huh?
See what is
Say again.
what's opposite from 12?
Okay, opposite from 12?
Dude, stop.
So why do you want what's opposite from 12?
Wait, what is it?
Ren, you're skipping an important step. What is the first thing we should do before we start looking at the triangle itself?
The cosine equals
The cosine stuff, right? Like what is the ratio?
A.
So cosine is what ratio? Am I just going to write adjacent to what? To A, divided by hypotenuse. Now, let's pause for a second, because I know, and I heard Kelsey already go, ugh. Here's the thing, guys. This is why I ask you to write this out. Doesn't angle C also have a side that is adjacent to it? Yes. So we have to be very clear about what our reference angle is. If you're not clear about your reference angle, this is when you get lost, and I have tutored a lot of students who get lost on trig. And let's be real, did this trig stuff show up a lot on the ACT last week?
I have no idea.
You know what shows up almost more than any other topic on the ACT? Trig. Lots of questions, and I won't say like 100 of them, but like 3 to 5 questions out of all 60, right? There's only 60 questions that cover all of math in high school. 3 to 5 of them are coming from trig. You got to know what trig is. So the adjacent to A divided by the hypotenuse. Now, notice, Ren, do we want anything that is opposite the 12? Nope. Okay, so we want adjacent to 12? Look again at that ratio. Adjacent to A. Remember, it's always in reference to the angle. London, what is adjacent to A? Okay, see, I'm hearing 12 and I'm hearing 37. Okay, so I'm going to come back to. Oh, so we need to remember that this 37 is my hypotenuse. Can that ever be the adjacent? No. So what's adjacent? 12. Next to. And this is something that I brought up last week, specifically group 7, I talked about this. What side should we always identify first? Hypotenuse. If you identify the hypotenuse, it makes the rest of it easy. So now, the cosine of angle A. So, Ren, what's going to take the place of the adjacent to A? 12. Claire, what's going to take the place of the hypotenuse? There we go. There is the cosine of angle A. Now you might want to use a calculator to see if it simplifies, but I don't believe it does. Check me on that. It doesn't?
We
Say
press
again?
control enter though.
Huh?
Control command enter.
But you don't want it. You don't want a decimal. All the answers are fractions.
So just simplify or just press enter again.
No, just that's as simple as it gets.
I thought you were supposed to go to your menu. But it's a fraction, right?
It's already a fraction. What you're thinking about is making it a fraction from a decimal. I don't want to do that. I already have the fraction. I'm good.
Okay.
There are sometimes you want fractions, or sometimes you want decimals. All these answers are already in fractions, so we're going to keep it in fractions.
Hold
I'm not holding on for number 11. That was forever and a day ago.
on. I got it. There you go. I wrote all the notes.
Well, you want to sit down somewhere?
So Jalen, I believe this was your group, wasn't it? Number 6? This was your group?
Yeah.
Oh.
She did.
Yeah.
Okay. Jalen, did you have a question about it, or was it Anton? Anton? Why is your head down?
Because he's not working.
Why are your eyes so red?
Ooh, what you gonna do? Alright, nigga, hurry up.
How am I going to figure out the tangent of 45? You asked about number 6?
That's how you hide.
He asked for number 19.
He asked for 19.
You're right. Jalen, so you asked about number 6.
Then it was you, did you?
No, we changed. Oh, no.
Alright, so guys, skip number 6?
No, we need to do it. Let's do it.
Alright. So guys, tell me how I can start the tangent of 45 degrees. What do you mean? It's a trig circuit. So like, once you completed this one, the sine of A ended up being 35 divided by 37. You said you had to figure out where 35 divided by 37 was. And that was number 2. So this one, 35 divided by 37, that's number 2. Alright, Kyson. What's the first thing we need to do for tangent of 45 degrees?
I don't know.
Find the adjacent and the hypotenuse.
Adjacent hypotenuse, that's tangent. Remember, tangent's here, so I need,
The opposite?
right?
Yeah.
Okay? So tangent of 45 degrees, and remember, you just said I need to identify opposite and adjacent. You need to write that out. Like, don't jump to the numbers right away. Write out the fraction. Opposite from what? And then? Brandon, you understood all this perfectly?
Right. Let's get
Opposite from your reference angle and adjacent to your reference angle. You gotta be careful about that. Tangent of 45 degrees then. Hey, which angle am I supposed to look at?
What do you mean?
Both of them. They both the same one.
They're both the same?
They both
So does it matter which angle I'm looking at?
No.
Let's check to make sure. What's opposite from 45? 3. Divided by what's adjacent?
You got 45. It's 45. It's 45.
What?
It's right angle.
It's on there, isn't it? I just forgot to write it. So that's adjacent. Let's pause for a second though. Michaela, can you tell me why this is adjacent and not this? It's the what? This one's the hypotenuse? Okay. Bashar, why did she say that this is my hypotenuse? Why is Michaela saying that this is my hypotenuse? Why is that the hypotenuse? What makes it the hypotenuse?
It's across from the right angle.
It's across from the right angle. That's what we want to recognize, right? If that's hypotenuse, this is adjacent. So what? Yes, ma'am.
So wouldn't it be the
opposite be made? So,
Opposite,
wait, hold on, so how is the opposite?
Jason.
To what? No.
I mean, they both the same number either way.
Opposite from 45 degrees
Oh, okay.
and adjacent to the 45 degrees.
So you going?
So tangent of 45 degrees is what?
3? Oh.
One.
Thank you. 3 divided by 3 is just 1,
Oh, we don't divide. Oh, my bad. I
right? Remember, it's a ratio, we're dividing. Now, if I look at this as my reference angle instead, what would the opposite be in that case?
The 3. What is
It's
that?
still 3, isn't it?
It's
And what would be the adjacent?
3.
So did it matter
No.
which 45 degree angle I use as my reference angle?
No.
Okay, but what if they were
It's big on 1.
Is it possible for them to not be the same?
Yes. What? No. That's fine. No.
So,
No.
we haven't gotten a chance to talk about it yet, but I'll go ahead and talk about it really quickly here. If these angles are the same, the sides opposite them have to be the same. That's one of the geometric principles, that sides opposite from congruent angles are also congruent. So, to give us a little bit better understanding of that, if I draw this triangle, say this is 70 and 70, let's say this is 10.
Uh-huh.
How long does this have to be?
10.
That's all it is.
It's on the same.
So, if these angles are congruent, the sides opposite them also have to be congruent.
Do the top have to be moved? I know.
Okay? And so, Kelsey, if I had something like this, any guesses
6.
what this angle would have to be? Right.
You gotta take one.
Well, if that's 60 and that's 60, this would also have to be,
60.
what's that to add up to be? 180. Oh, and if this is 60, what does this have to be?
60. No, that's 5. Yeah,
Remember, this is known as an equiangular or equilateral triangle. Actually, did we talk about that this year?
No.
Something you should have
I
talked
heard
about in middle school.
equilateral,
What about that? Girl, we've already talked about everything on the front page. Reference angle, hypotenuse, opposite side and adjacent side, angle, angle similarity theorem, right triangle trigonometry, sine of theta, cosine of theta, and tangent of theta.
When do we turn that in?
I have it in the slides, which so I'll put it up at the end of class.
When do we turn that in?
It's in the slides, I'll put it up at the end of class. Or I'll write it down at the end of class. What? No, I'm teaching you. Alright. Gentlemen, do y'all all understand that sides opposite equal angles, or congruent angles have to also be congruent? Okay. So that was number 6, we're down to 19. What, Terrence? Huh?
You what?
You said
No,
you
no,
come
no,
If
here.
no.
you want to walk your tail up here, you can talk to me, but I'm teaching.
Yeah, I need 6 feet apart, so I think you got this stuff. They don't know.
Is it safe? Yeah, is it safe to say one of the biggest things on here was the square root again?
Yeah.
Is that the issue? Okay. Now, this is the triangle that was given, but I will point this out. Looking at that triangle, is there anything about this triangle that doesn't make a lot of sense? So, anything about this triangle that doesn't make sense?
All the sides are 20.
Look at those angles again.
What I ain't looking at?
Y'all, stop. Terrence is trying to play it up so that he can get out of here. He's not actually sick. He just doesn't want to be here. So, look at those angles again. You're telling me that those angle measures make sense.
Oh, wait,
What
no.
number we on?
Number 19.
That's not 30.
There's no way that that's 30 degrees if that's 60. And that's just the way it was drawn. It was not drawn to scale, but I do want you to notice that. This doesn't make a lot of sense, but we will still answer this question off of this. So, let's see, someone I haven't called on yet. Jordan, how are we going to get started? All right, I'll get to you next. Jordan, how are we going to get started on figuring out the tangent of 60 degrees?
What we on?
You have no clue. Have you paid attention to a single thing we talked about today? So you haven't heard us talk about the tangent at all.
What is a tangent?
It's a trigonometric ratio that we have talked about multiple times today.
Somebody thing up there?
It's part of it. Jordan, you need to pay attention to this as someone else explains it, because we've been over it multiple times just today, and I know you were here for at least part of this last week. Josh starts off. Yeah, you had your hand up first before anyone else. Talk about the tangent of 60.
Opposite from 90.
So opposite from 90 degrees.
Wait,
You want to modify something?
oh yeah, 60, my fault.
Oh yeah, it's the tangent of 60 degrees, so it needs to be the opposite from 60 degrees.
Nope.
Then what?
Adjacent from 60. Wait, yeah.
And well, we would say adjacent to 60. I feel like I'm missing something.
Oh, with the division bar.
Division bar, right? The fraction bar. Okay? Alright, you had your hand up pretty quickly. Can you tell me what side is opposite from 60 degrees?
Oh.
You can't tell me? It's okay to get it wrong. It's not okay to not try. Alright, come on.
Wait.
4 squared to 3? So you think this side is opposite?
When you do opposite, which way you going when you doing opposite? Like, is it a certain way you go?
Opposite means across from.
Oh,
Oh, she got that right.
oh, okay.
Yeah?
See you are.
4 squared to 3 is across from 60? Yeah. Alright, alright. Rose, can you tell us what adjacent would be?
Beat that upon 3%.
The 4? And we know that the 4 is adjacent because what's the hypotenuse? 8.
Oh.
Right? That's a big part of that story, is that we need to know what the hypotenuse is. Hey, Terrence, what you doing in your backpack back there, buddy? Why is your phone not over here? Dude, you got 30 minutes of class left. Put the backpack down, get off your phone, because you're not supposed to be on your phone in the first place, it's supposed to be put up here. Thank you, sir. So, tangent of 60 degrees is equal to opposite 4 squared root of 3 divided by adjacent of 4.
How you supposed to do that?
Yeah, what's 4 divided by 4?
4 is 1.
So, yeah, what about
What's 1 times the square root of 3?
3?
And technically it's divided by 1, but I don't need to write divided by 1.
So you want to do 4 squared, or 4...
Okay, really quickly to clarify, I feel like some of y'all are forgetting that 4 squared root of 3 is 4 times the square root of 3. That's what that means. Just like if it was 4x, what does 4x really mean? 4 times x. If I had 4x divided by 4, what's 4 divided by 4? So you would just write that as x, correct?
Right.
So then if I were to have 4 squared root of 3 divided by 4, 4 divided by 4 is 1, so I'd be left with the square root of 3. That's it. Okay. Any questions about number 19?
No.
Jordan, I'm giving you a heads up, number 15, I'm coming to you. So you better start looking at it.
Wait, what? You did what? I didn't know.
Boy.
Oh, I don't think I got that. I think I just wrote it.
Number 15.
Let me.
Okay? So Jordan, how am I going to start the tangent of angle C here? The hypotenuse? You know we just did tangent, right? Just did tangent.
But opposites.
It says.
What two sides did we need for tangent? Opposite and adjacent. Jordan, are you trying? Like legitimately, are you putting in your best effort today? It's not funny, man. Like you can do much better, and you're selling yourself short. All right, Kyson.
Man, it's the opposite and adjacent.
Okay. Opposite divided by adjacent. Is that going to earn full credit?
No.
What do I still need?
Numbers.
Opposite from C, or opposite of C, divided by adjacent to angle C. Right? Do not forget, Jordan, how do we calculate tangent? It's what divided by what?
Opposite divided by adjacent.
Uh-huh. And if you ever forget, remember we have this little acronym TOA, the back part of that tells us tangent, opposite divided by adjacent. All right? Yes, sir.
Oh, God. That's a 7 type one. That's a 7's dangerous. What's 20? So I'm gonna blow my nose.
You can grab a tissue right here and step right outside the door. So, someone I haven't called on in a minute. Dee Dee,
Huh?
what's opposite of C?
What's opposite of C? What's C it? Oh, be quiet. Opposite going across over there. Oh, it's A. No.
So, A is
Hold
opposite?
on, said opposite of C.
Uh-huh. Opposite of angle C. So right here?
Hold up. Opposite.
Hold on.
Wait a minute.
Say that again.
The opposite of.
Now, there is one thing I guess that we should remember to write up here.
I just ate that.
What is, when we say opposite, what kind of opposite? Are we talking about an angle or a side?
The side.
So we really should write side opposite of C and side
Oh, we talking about the
adjacent.
side. The side.
Yes.
Oh.
That's what we need to remember. When we say opposite and adjacent, we are talking about in respect to an angle, but we're trying to get sides. Sorry, I forgot that I have middle schoolers in here that are trying to play footsie. Yes, ma'am. So, Dee Dee, what do you think about that? The 28 being opposite.
Take that as angle.
I say.
Remember, what else do we mean by opposite?
Across. What
Across
side?
from?
Side.
Nope. Oh, it's a side across from. Come on, let's go. Is 28 across from the angle C?
Yes.
Yes.
Yeah. So there's my opposite. All right.
And yours too.
Rose, can you tell us what's adjacent? 21.
21.
And again, why is that adjacent and not the 35? I mean, 35 is next to it as well. 35 is my hypotenuse. Remember, label these different features, and then it makes it much easier to make sure you get the ratios right. Tangent of angle C is equal to,
48 or 21. 28 divided by
and then we need to check if we can simplify that. 4 divided by 3.
Don't even say nothing about that.
That's what we're working on right now.
This gonna be so great.
We're gonna have another sentence check.
Hey, Aaron, look here.
It was just a number, there was no name that popped up with it. Thank you, thank you, thank you. So what we're going to learn about today is how not just to calculate a trig ratio, or the new thing we're learning today is not just how to calculate a trig ratio, but how to use a trig ratio to solve a triangle. Okay? We're going to learn how to use a trig ratio to solve a triangle. So, really quickly, I'm going to define a key idea for you. Actually, I'm going to come back to that later. I'm going to do something else first. So, solving right triangles with trig functions. Please hear me very clearly on this. Scratch out the word functions and put the word ratios. We're not using trig functions, we are using trig ratios. A function is a graph with both inputs and outputs. We don't have that. Okay? So we are on trig ratios. The first triangle we have here is this triangle. Okay? There's the first triangle. Now, I do want to quickly remind you, can we use trig ratios if the triangle is not a right triangle?
Yes.
No.
You can. Hey, why is that?
Because it ain't right.
Okay, one of the things is you need a hypotenuse, yes, but go back to the original thing. What was the idea of trig ratios built out of? What kind of triangles?
Right angle. Right triangle. Six.
Similar triangles. Do not forget that everything was built out of the idea of similar triangles. Because if I know that this angle right here is 34 degrees, and this is 90 degrees, what do I know this angle is going to be?
City.
56? How are we getting 56? And I want y'all to hear this very clearly, because Alana hit on a really important idea. Notice, if this angle is 90 degrees, right here, if this is 90, what do the other two angles have to add up to be?
180. Oh, 90. Oh.
Right. Remember, if there is 90 degrees tied up right here, the other two angles have to add up to be 90. That's a quick way to figure out what that third angle is. And what do we know about all triangles that have a 34, 56, and 90 degree angle? I mean, all triangles sum up to be 180 for the angles. But what do I know about these two triangles? Even though they're different sizes.
Similar.
They're similar, so they have the same
Size. Ratio.
ratios. I need y'all to remember that everything with trig ratios is built out of similar triangles. Because even though they're different sizes, they would have the same ratios. And that's what it is, trigonometric ratios. So,
I got 32.
looking up here, remember that doesn't work unless we have a right triangle because we don't know what the other angle would be. But when I look up here, I want y'all to use, remember we weren't originally given that 56 degrees. So I want us to think about, hey, there is an angle, a reference angle, 34 degrees. Look at the side that we're trying to find. look at the other side that is given and figure out which trig ratio we might be able to use. I'm going to give you 60 seconds. Actually, let's go 45 seconds to think silently on your own, and then I'm going to give you a chance to talk with your group. Which trig ratio should we use based on what information is given in number 1? Should we be using sine, cosine, or tangent? 45 seconds to think on your own.
Go to the bathroom.
Yeah. Yo, I asked you to think on your own. Are we ready to talk as a group?
Yes.
Not all of us. Some of us still need some think time. Be respectful of that. Why are y'all talking? Be respectful of the people who still need think time. Alright, now talk with your small group to figure out what trig ratio we're going to use. Dude, I literally said Snapchat. Or Instagram. Oh, no, push your phone away. Put your phone away. Put your phone away. See, like, to me, this issue, you lied to me about Instagram earlier when you were texting me on Then why were you on Instagram? No.
My granddad.
You can't keep your story straight. It's hard for me to trust you. Put your phone away. Thank you. Claire, what trig ratio did your group come up with? Tangent?
Yep.
Okay, tangent of what?
Tan of 56.
Tangent of 56? No, because remember, do we have a C here?
No.
No? So which angle are, remember, first off, which angle did I tell y'all to use? I already circled it.
Oh, my bad.
Tangent of 34? Alright. So tangent at 34 degrees. Alright, how do we calculate tangent? Okay, what side is opposite from 34?
Yes.
Side, right? So side, opposite from 34 degrees divided by the side adjacent to? Okay, so the side opposite was x. What side is adjacent to 34 degrees? Is it?
90.
No.
Wait, what?
The side is not like
10?
Notice 10 is,
Yeah,
10 is what? 10 is the hypotenuse, y'all. Do I know what my adjacent side length is? I don't know the adjacent side length. So can I use tangent?
No.
What can I use? So I'm looking for the side opposite. That's good. But which side did I have again?
Oh, sin.
The hypotenuse?
Sin.
nine.
Say it
Sine, my
properly
bad,
for me again.
sine.
Sine. So I'm using the sine of 34 degrees.
Well, hold on, what we doing? What we doing?
It's an abbreviation for the word SI
What we writing down?
because it's sine and it's cosine and it's tangent. I feel like I'm having deja vu because I had this exact discussion on Thursday
Wait, so.
when you were here. I need you to pay attention because I taught all this once. And by once, multiple times. Yeah, sorry.
Okay, so like, I know how we got that. So, since we talked about So it'll be like something like hypotenuse that we already got, like the numbers
Well,
we already got.
and so we already know the hypotenuse, right?
Yes.
Now, here's the thing. We actually did this once already with the calculator. Does the calculator already know what the ratio of sine of 34 degrees is? Yes. So remember, and that was the point of me talking about those triangles, those similar triangles earlier. Guys, eyes up here. This is the whole point of me talking about similar triangles earlier, is I don't know exactly what the ratio is, but is the ratio ever going to change for a 34, 56, 90 degree triangle? No. The ratio of the opposite to the hypotenuse will never change. So how can I figure out what that ratio is?
Subtract, divide, multiply,
There's a variable there, y'all. I can't divide.
x,
Oh, what?
multiply.
Why doesn't everybody pick up a calculator and hit the trig button? Yep, there's a trig button.
Where?
Find the equal sign.
Sin.
So you're going to do sine of... No, because we're not taking the sine of x. We're taking the sine of what? 34.
Oh. 0.529.
0.55...
I said 529.
Was it 5.2?
Yeah.
5 now.
Yeah, 5591.
You can find two something. No. So I had to hit that.
I know they ain't do all that, because I ain't even trying to do that.
There's no way that
I
happens there
was
without
walking
you
by,
trying.
and he
No.
choked me off.
Go ahead.
Both of you two, or
I ain't
you,
moving.
stop,
I ain't moving.
stop,
Mostly.
stop. You two are staying after class, we're gonna have a conversation on this after class. Stop, stop. I'm busy teaching right now, I don't have time to handle this right now. I'll talk to you after class. So, sine of 34 degrees, we get 0.5591. Now, did you get something different, Kyson? Did anybody else get something different than 0.5591?
No, I didn't.
You did not? Kyson, look at the top right-hand corner. Does it say degree or radian?
Radiant.
It says RAD at the top right?
Yeah.
So that's the issue. We need our calculators and...
You just gotta tap on that.
Oh, that's right. Oh, go back. Guys, if it doesn't say DEG in the top right-hand corner, you will not get the right answer. So I need everybody to take the sine of 34 degrees in their calculator right now to make sure they get the right ratio. It should say DEG for degrees. Okay? Now, really quickly, eyes and ears up here. Is that a ratio? Or would you traditionally think about that as a ratio?
No.
Is there a way to make it a ratio?
Yes.
How?
I don't know.
I heard someone say make it a fraction. What can I put in the denominator so it's the same number?
1.
5. Oh.
Okay.
I just answered.
Please notice, right? The right-hand side is still x divided by 10. But the left-hand side is 0.5591 to 1. Notice what we're saying is the sine of 34 degrees. In a 34-degree angle, the side opposite is 0.5591 when the hypotenuse is 1.
1.
So that is a ratio. You can scale it up, you can scale it down, and play around with it. Okay? But it doesn't have to be any more complicated than this. How am I going to solve this equation to find x?
Divide by 2.
Yo, look at this equation again.
Divide by 0.5.
I want to solve for x. Say that one more time. Undo the last operation being done. Caleb, what's happening to x right now that we can undo? Yeah, because you ain't paying attention. But look again. You're telling me you don't know how to handle x divided by 10. I don't care about whether you're looking before. You have solved an equation like this. You don't know how to take care of x divided by 10. then you need to pay attention. Does anybody else know how to do x divided by 10 or take care of that?
Yes.
Kelsey, say again.
Multiply times 10.
Multiply by 10, would that undo division by 10? Then stop playing around, pay attention. I had already moved on because you were like, oh, I don't know how to do that. I didn't hear you because I was talking to somebody else because you stop, dude. Just quit. Stop. Stop. So, just because I already have things labeled over there.
Oh.
Are you okay?
So Kelsey said multiply by 10. Ari, what is 10 divided by 10?
1.
1?
No, 1.
And Brooke, why did I multiply by 10 on this side as well?
So you cradle.
Why are there so many conversations when I specifically asked Brooke why I multiplied the left-hand side by 10 as well?
What you do to one side, you have to do the other.
Okay, why do we have to do it to the other? I have to make those equations equivalent. You don't have to make it more complicated than this. Just pick up a calculator. Oh, by the way, I do want to remind you, how many decimal places do we want to go to?
4. 2. Yeah, 4.
4. When you do trig ratios, go to 4 decimal places. Okay? But then pick up a calculator. What is 10 times 0.5591?
I got 5.591.
5.9.
Equals 8.
Is that X?
That's it. We're done.
So you're making trig in algebra?
Trig involves algebra. Yes.
So why everything in math connects with each other? Like, that's just...
Because that's how life is. That's how math is. That's the thing. We're used to being taught that math is all these different things that don't connect. No, everything in math connects. And when you learn to look for those connections, it makes math, 1, more enjoyable, and 2, way easier to learn. Yes, Dee. So, I multiply both sides of the equation by 10. And so 10 times this divided by 1. Right? Because 10 is understood to be in the numerator. Now, I will say this, and I need you to hear me very clearly on this because this is important long term. I have not finished solving this triangle. I know that x is 5.591. I know the hypotenuse is 10. I know that this angle is 34 degrees, and I know this angle is 56 degrees, and this one is 90. So what do you think I mean by I have not finished solving this triangle?
You haven't done the bottom yet?
You still gotta do the opposite side divided by the hypotenuse.
I don't need a ratio to finish solving it. So, what were you saying though, Ari? M? Where do you have M? Say again? Oh, that's 10 meters. I got you now. That's 10 meters.
Move.
Is there anything from that triangle that we don't know yet?
Oh,
The bottom side. So, what do I mean by solving the right triangle?
By having all the side measures or calculations.
So if I ever ask you to solve the right triangle, what you need to have is you need to know / solve for all what? Side lengths and angle measures. Okay? We only have a few minutes left, but I do want to give you all a couple minutes within your small groups. Figure out how we are going to solve for that last side so that we have finished solving for that right triangle. Talk within your small groups how we're going to finish solving for that final unknown side. Josh, it helps to have our head up. So we can talk. Sir. Oh, I literally watched you just randomly highlight stuff.
You so did. I did.
You know there's a second page, right?
Wait. Can you take this one? Cause I'm in the
Hey, stop. I need y'all working on this number one so that you know how to solve for that triangle. Come on. Put it away so that you can work on math. Notice we saw not found this on the side. So we know 10 meters and now this is 591.
We take notes.
10 times that. Y'all, you need to at least. I see a whole bunch of people talking about nonsense that has nothing to do with this math. That's fine. I would agree that that is not right. Why did you have those two sides? Well, I think y'all are getting some ideas, but there is a part that relates all the sides. So why do y'all use Still number one, we gotta finish off that side. The bottom side of the bro, you put up your faces. Where C is your way? So 5.591 squared plus So which angle are you using as your reference? Is the bottom side adjacent to the 56 though?
Oh my God, you're not letting me
Thank you. Thank you. Thank you. So I want to grab your attention because I actually heard two really good strategies already show up. And this is what we want to be aware of. Group 2, what was your strategy to find that third side? Pythagorean theorem. When can you use the Pythagorean theorem? When you have a missing side of what kind of triangle? A right triangle. Terrence, what is the Pythagorean theorem? Ooh, okay. A squared plus B squared equals C squared, or plus C squared? Do we need to modify that at all, or are we all good? It equals C squared.
I said equals.
But I heard you say plus. So, what do we mean by C? Hypotenuse. What is my hypotenuse? 10.
Good afternoon, Hillcrest. Your meeting tomorrow, December 7th at 3:30 for anyone wanting to try out for the track team.
Just hold on a
The meeting
second.
will be in front of the school.
Okay.
All those wanting to try out must attend.
We're not going to finish solving it. That's okay. London, what was your strategy?
Have fun. Have a marvelous Monday and be one happy.
Okay, so, now, hey, listen, which angle were you looking at again? I think you said 56, right? That one?
Yeah, but then I heard you.
So I need y'all to look at this. Hey, stop and listen. Y'all, at least take 30 seconds. I still got at least that time. 30 seconds. 34 degrees is right here. What side are we missing in reference to that? The adjacent, and we have the... So, is London correct that we can do cosine of 34 degrees is equal to adjacent divided by 10, the hypotenuse? Which one do you think is going to be easier? Guess what? It's your choice. I personally would go with this one, but it is important to notice that there are multiple strategies. Alright, let me put your homework up really quickly.
Hold on.
Uh,
Oh,